Hello everyone and welcome back to Kanai's AI Lab. In this video, I will demonstrate deep learning and LSTM, long short-term memory neural network, to predict Nifty 100 stock prices for next 15 days. As we all know, stock market prediction is a challenging task due to the heavy complex pattern in the data. However, with the help of AI models like LSTM, we can analyze past trends and make informed predictions. So our problem statement is very simple. To predict the next 15 days closing price of Nifty 100 index using historical stock price data. So let us see how I taken the data for training purpose. So this is a Nifty website. You can select what is your equity. I'm selecting equity in this case and I have taken the index of Nifty 100 and you have to select the time period. For this particular sample data, I have taken from 28th March 2024 till today. So the data set is saving in terms of CSV format, which I am going to use in this particular problem. So let us see the data sets in the code itself. So our aim is to implement LSTM, which is a powerful deep learning model for time series forecasting. And we will be visualizing the prediction and comparing them with the actual data. So why we are preferring LSTM? Because most of the traditional machine learning models may fail to capture this sequential pattern of the data. So let us use LSTM in this case. So we will be deep diving into the code now. As a first step, we will be importing the necessary libraries. So we will be using NumPy, some numerical computations are there, and Pandas and Matplotlib for visualization. And we will be using sklearn for scaling the data by using min-max scaler function. And we will be using the framework of TensorFlow, which is a compatible for Keras, which is compatible for neural network as well. So we will be importing TensorFlow and we will be importing the model from TensorFlow with Keras API inbuilt. So let us run this code to load the necessary libraries. So this loading is happening now. So once the loading is completed, we will be connecting our data to the code. So my data is available in the drive. So the drive will be connecting with this code. So now we are into the process of library installation. Let us complete the library. Immediately after, we will be connecting the Google Colab. You can see that I'm connecting. This is called mounting to the drive. It's mounting to the drive. It's asking connect to the Google Drive. I have to pass my account. Then I have to use some declaration. Continuing. After that, just click on continue. This process will help you to mount the drive. After that, you can see the drive will be mounted. I will show where the data is saved in this particular cases. Once the drive mounting is completed, I'm just looking where is my data. You can go to drive. You can go to mount my drive. So here is my folder Nifty stock price prediction. Within that, you can see my data name Nifty underscore 100 in CSV format. You can use the option of copy path. Using that particular, I'm going to paste the link here and connecting the data and saving the data in terms of a data frame, which naming DF in this case, loading the first 3 rows of the data. You can see this is the data. We have Nifty 100 and the date starts from 27th March 2025. And we have the details of open price, high, low, and the close price of the Nifty 100 stock. So once the data loading is completed, we are going to convert the date column into the correct format by using the pandas datetime function. You can see here pandas datetime function and converting the date into the format day, month, and year. And if needed, we can sort the values in terms of function sort underscore value. Since ours is already sorted data from date by date, not needed, but this is a normal practice. So with that, just clicking and converted the data column. Now, after converting the data column, we are going to normalize the data between 0 and 1 using the function called minimax scaler. You can see this is the minimax scaler. So why do we need to normalize? It's very important. LSTM works better with small numerical value. Sometimes the numerical value, the price data will be large. So LSTM work with best and small numerical value. So we need to scale the data between 0 and 1. There are also some other function available other than min-max. So I am taking the target value in this case. So what is my target? From now onwards, I am going to find my y as the closed column of the data, and I'm going to reshape into -1 and 1. So the reshaping is required because LSTM need one day array for the calculation purpose. Let me run both cells. Yeah, close price final target is selected, then normalized. Once after normalizing, we will be using a special function. So we will be preparing the sequences of past prices to predict the next day price. So we have a function create underscore sequence. You can see here, which extract 30-day windows of past stock prices in X and this corresponding next day prices is Y. So as I mentioned here, I am giving 30 as the number of past days for prediction. It uses the numpy's one particular function called sliding window view. This sliding window view technique to efficiently create overlapping sequences. So here in this case, the finally we will be taking 30 days of closing price and which is in X, while the output Y is the stock price of the next day. So final, we will be reshaping X into samples, time steps, features, which is LSTM required in terms of sample, in this case, number of sequences. The timestamp we are going to given as 30 days, and the feature we have only one, which is nothing but our target, which is close price. Maybe if you want, you can take the shape of your X and Y now. I have around 219 values of X and 30 is the number of days and one particular array. This is one day array. Shape of the Y, we can see that there are 219 predictions of Y are there. 219 values of Y, not the prediction. Very sorry for that. So with that, we are going to define our model. Have you heard about LSTM before? So LSTM or long short-term memory is a type of neural network, which is something we'll call it as a RNN, recurrent neural network, that is designed to learn patterns from sequential data. So time series is a sequential data and natural language is a sequential data. LSTM work better with time series data. That's why we are taking stock price prediction for LSTM. So unlike standard neural network, LSTM have a memory mechanism that allows to retain the important information over long sequences. This makes them highly effective for stock market prediction as they can analyze historical trends and make accurate forecasts. So with this understanding of RNN, that is recurrent neural network, so we are going to define our LSTM model. I am going to take sequential model from the Keras API, and my first layer, it will be having LSTM has 50 neurons. I am passing the input shape as sequence length, comma 1, which is prepared in the last step. And I'm going to add next as 20% dropout layer. Sometime overfitting may happen. I want to avoid the overfitting. May not be completely not possible. I'm using a layer of dropout for 20%. Then we adding a dense layer. So before adding the dense layer, you can see here, I added one more LSTM with the 50 neuron with same pattern. Again, dropout of 0.2. The number of layers you can add, it's like a trial and error only, which works for the better prediction. So we finalize with a fully connected dense layer, which is used to generate the final prediction. So this is dense of 1, which produce the final prediction. So once we clear about the structure of our neural network, we are going to compile it. While compiling, we need to identify which kind of optimizer you are going to use that particular application. We will be using Adam in this case. Also, I have to provide what kind of loss function for the back propagation. Once the model is trained, it has to update the different weights. We need to provide some kind of loss function. The loss function is going to optimize by using the Adam. So we will be using mean squared error in this case because this is a numerical data prediction. So I'm going to compile it with optimizer and loss function. So once the structuring, that is model defining or compiling, is completed, we are going to tell the machine, please run it, or train the machine or learn the machine. So we are going to train the model by using the fit function. We are going to pass our X and we are going to pass our Y, which is the close price. And we are going to run this complete training with 50 epoch, and we will be dividing the data into batch size of 16. So let me run this. This model training will take some amount of time. So let's see how fast this is going to train. It's completed 8 epoch already. It's moving very fast. So let us wait for the complete training. You can see here loss function is reducing on each and every epoch. So this epoch will be validating again with the loss functions. Training accuracy, testing accuracy, everything will be happening in the backend. So accuracy is going to increase and loss function is going to decrease. This is the principle of training. Once the training is over, you can see here, it's almost how many minutes. You can compute how many 14, almost 10 to 20 seconds it took. Maximum of 30 seconds. I didn't compute. I'm very sorry for that. So once the model training is over, we can go ahead with the predictions. In this case, we are going to predict the next 15 days what is going to happen. So what we are going to take, we will be taking for the comparison last 30 days of real data, and we feed into the model. The model predict 1 day at a time and update the input sequence with new predicted price. Since the model outputs the normalized value, since we have done min-max scaler, so we may not be able to read the data properly. So we may need to reshape into back. So that's what reshape of 1, 1, 1 on axis is equal to 1. So this is all about the syntax of predicting for next 15 days. So initially I given an empty list. Then I've given what is last 30 days. Then the for loop for prediction 1 by 1 for 15 days. So finally the prediction is going to append on the empty list with the values. So last 30 days update will be happening like this. You can see here this prediction is happened with this much amount of time. Now we are going to convert the prediction back to original scale. As I mentioned, I need to reshape it to -1, 1, which will be having a column with -1, 1. Reshaping, you can learn what is reshaping. So we are going to find out what is my future date. My future date is nothing but 15 days of period with the time delta adding what is date today. This is 28. From starting from today, it's going to identify what is the next 15 days. After that, it is going to forecast PD.date data frame. So it's predicting close price and finally printing the prediction for all the 15 days. You can see here, so starting from today, the predicting price is here up to April 11, 2025. So the exact prediction is here. So once the prediction is here, we need to plot. So always visualization is always very good for better visibility, right? So we plot for last 10 days of real stock, which is in blue color, and the rest is in the other green color. So what is happened? So we have the train date. So we need at least to showcase how the trend in the last 10 days, and followed with another type of line which we need for 15 days from starting today. So we are creating the data frame prediction of 15 days and last 10 days of training data, and we are keeping a figure size of 14 and 2, and we are going to plot first the train days because that's last 10 days for identify how last 10 days it went. It will be in the blue in color, and it is labeling last 10 day training period. And we are going to visualize the prediction with future date. Future date is already there, it is. So which will be the predicted price and which will be marked like this. And this is called styling of the plot, right? So we don't want to focus too much on the styling on the plot. So we will be giving X label, Y label and title. So let's see how the plot is for prediction as well as last 10-day trend. So let's execute this. You can see a beautiful picture. So we have blue color for last 10 days training data, and we have a green for next 15 days of predicted. We have a beautiful prediction. We are not sure whether this is going to be very accurate, but LSTM makes a decent prediction based upon the data we have given. This is Nifty 100 data. So we predicted the stock price for next 15 days using LSTM. We learned the pattern from the model and we predicted the future stock price. So AI-based forecasting can help investors make method decision in the stock market. I hope you found this video useful. Don't forget to follow for more informative content with Kanai's AI Lab. Thank you once again for joining this video.